of the committees and to Professor Zhao Ping for the nomination. Okay, my topic is new applications and prospects of semiconductor optical amplifier, more than just amplification. In my following section, I will deliver my speech from two parts. First, characteristics and applications of semiconductor optical amplifier. As we know, SOA is a PN junction with strand quantum wave structure. After the entry of the external light, it triggers optical signal amplification. Initially, we used SOA as amplifiers, but in practice, SOA has its volatility, such as it can be used as superluminescence diode, like a wide spectral light sources, and applied in channel fulfilling WPN-PAM transceivers and detection of passive devices. And SOA, reflective SOA, combination of silicon-based external cavity laser. It can be made up to external cavity nanoline-wise laser, and it also can be used in optical wavelengths converter because of its nonlinear effects. And it can be also used for the optical switches array in high-speed data center. In optical sensing system, SOA can be used to replace acoustic optical modulator, and also even in the shorter reach connections, it can replace erbium optic fiber amplifiers because of its high extinction ratios. And in front of the external cavity laser, integrated reflective SOA. And SOA can be used VOA and waveguide PD. Okay, this is the SOA application overview. Optical sensing, optical transmission, and optical computing. I will introduce some details in my following presentations. Currently, the largest incremental market lies in optical communication, including transmission network and access network, and additionally, rapidly emerging application area like satellite communication require SOA for low power consumption, high integration, radiation resistance. Okay, to break down, there are several specific scenarios for inline amplification, like multi-band transmission, single wavelength multi-stage amplification to replace erbium doped fiber amplifier. And even between the data center, exists some monitoring. Wherever the split is needed, SOA can satisfy these scenarios. This is a diagram for two types of optical transceivers. Optical transceivers can be divided into line side and client side. There are five yellow SOA chips in the line side systems, and on the right is the client side optical transceiver, usually short-term reach connections like 100G ER, 100ZR, and 4 multiplied by 25, 50, even 100G. This is diagram of ITLA named Integrated Tunable Laser Assembly. There are three mainstream diagram: DLP array, DVR, and ECL. ECL named external cavity laser. Usually a bandpass filter, usually silicon-based, and a gain chip and SOA. This is PAN amplification for access networks. The module support for parts, ChargeS PAN, Charge PAN, 10G PAN, and G PAN. The key technical challenge lies in amplifying the downstream, like 1577 and the 1490. We use two SOA chips to achieve the span about 90 nanometers. This is optical sensing systems. In these systems, SOA plays a role as chopper or modulator. In these systems, SOA can replace AOM, acoustical optical modulator. In shorter distance, can replace a dotted fiber amplifier because of its high extinction ratio than AOM. And in front end of external cavity laser, RSOA integrated. We even make a MOPA, Master Oscillator Power Amplifier, to integrate narrow line-wise laser and SOA into one butterfly. Makes it more compact size and cost-effective and lower power consumption. Other scenery is LiDAR. Traditional TOF LiDAR typically will not use SOA, but in the wind measurement LiDAR and in FMCW LiDAR, SOA plays a great role. In the wind measurement LiDAR, we invested MOPA to replace one narrow line-wise laser and one of the acoustical optical modulator, make all systems more compact size, cost-effective, and lower consumption. In the FMCW LiDAR, there is a need requirements for SOA with more higher output power. This is the application of optical coherent tomography, 1060 nanometer SOA for ophthalmic imaging and 1310 nanometer SOA for cardiac OCT imaging. A key characteristics of SOA is their ability to suppress noise. This is the SOA optical power transfer function, deep saturation region. We can see when the input power is sufficient, the output power entered in state saturation. Depend on the feature of saturation of SOA, it can reduce the ring less than GHz. This is SOA for narrow line-wise laser integration with a silicon photonic chip and fiber block grating and thin film lithium niobate and the ring cavity and the PPG. This is photonic integration as shown in the diagram. Passive components are standardized, and among them, SOA stand out as the key amplitude modulating component, uniquely serving as a GaN device in integrated systems. This picture shows some prospects of our investigation. We have realized hybrid integration, and in the future, we will realize monolithic integration. This integration drastically reduces size, weight, and power consumption while enhancing reliability and scalability. Okay, next is our some company and product introduction. Our company name is Tianjin Janhoo Optoelectronics, relying on the Tianjin Institute of Tsinghua University. We are a company specializing in development and investigation of SOA chips, SOA butterflies, and PIC devices. We can provide full range of SOAs from chip to COC to butterflies, and the wavelengths coverage from 1060 nanometers to 1625 nanometers. And we can also provide RSOA and superluminescence diode and narrow line-wise laser to corresponding wavelengths. Otherwise, we can also provide the PIC services. Okay, we stand out in the market with some key strengths. For example, full range of SOAs and full market domain in the scenarios. And we have 2 points I should mention. That is that first, we possess the polarization independent technology among some chip manufacturers of SOA all over the world. We just few companies possess this polarization independent technology. Okay. Second, we have our products have the more electro-optical conversion efficiency than other like a foreign brand of SOAs. Our output power is 4 times higher. This means more reliability and less dissipation. Okay, please follow our official WeChat, and we will release some new documents and technical information about semiconductor optical amplifiers. And this is our SOA technical white paper 2024. Feel free to contact us for delivery. Okay, thank you very much. That's all.